Bell ringer. Solve the triangle using the law of cosines. A cruise ship maintains an average speed of 15 knots in going from San Juan, Puerto Rico to Barbados, West Indies, a distance of 600 nautical miles. To avoid a tropical storm, the captain heads out of San Juan in a direction 20 degrees off a direct heading to Barbados. The captain maintains the 15-knot speed for 10 hours, after which the path to Barbados becomes clear of storms. Through what angle should the captain turn to head directly to Barbados? Once the turn is made, how long will it be before the ship reaches Barbados if the same 15-knot speed is maintained? So here in the diagram, you see that we have San Juan, Puerto Rico here. We have Barbados. The ship is headed this direction. It is an angle of 20 degrees off a direct path from San Juan to Barbados. So first, in order to find out through what angle that we need to turn to head directly to Barbados, we're going to first find out what this angle here is near the ship. So what I'm going to do is draw my own version of this diagram, because that's what I would do if I were working it on paper. So here we have San Juan. Okay, and here we have Barbados. So I'm going to draw a segment there. That distance is 600 nautical miles. Then the ship heads out 20 degrees in this direction, okay, until it's clear of the storm. And then the question is, what angle is this right here? What angle do we have here? Well, here's where our ship is. Now basically the ship is headed this direction. It continues in a straight line. So the course correction is going to be this angle out here. But before I can do that, I need to find out what this angle is. So I'm going to give these vertices a name. I'm going to call the ship angle, where the ship is, I'm going to call this angle A. Initially, I'm going to be speaking about the angle inside the triangle. I'm going to call San Juan point B and Barbados point C. Now, one thing that I can find is the distance from San Juan to where the ship is, because I know that the ship was traveling 15 knots, okay, and it did that for 10 hours, okay, so that's going to be a distance 150 nautical miles, so I will add that to my diagram, okay. So I will need this distance from the ship to Barbados, so I'm going to call that B. So A would be 600. B is what I'm looking for. C is the side opposite angle C, that's 150. And I know that angle B is 20 degrees. So I can use, I have a side angle side triangle, so I can use the law of cosines to find side B. So side B, using the law of cosines, would be B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. So B would be the square root of all of this. So I'm going to go ahead and fill in B is equal to 600 squared, the square root of 600 squared, plus 150 squared, minus 2 times 600 times 150 times the cosine of 20 degrees. So I went to my Desmos calculator and I put in that entire expression. So I am going to round this to 3 decimal places, 461.904. So now we know that that is the measure of side B, or the distance from Barbados to where the ship is 461.904 nautical miles. So now we want to find this angle inside the triangle. So we're going to call that angle A. So if I use the law of cosines for A, I would have A squared equals B squared plus C squared minus 2BC times the cosine of A. Well, I'm going to rewrite this. I'm going to move this expression, this entire expression, to the left side, and then I'm going to move the A squared to the right side. So I would subtract A. I would subtract A squared from both sides and add 2BC cosine of A to both sides. So I will have 2BC cosine of A equals B squared plus C squared. So now I'll divide both sides by 2BC. I forgot to put minus A squared. So this is what the cosine of A is equal to. So to find A, I'm going to use the inverse cosine of this expression, B squared plus C squared minus A squared divided by 2BC. All right, so I'm going to calculate that now. So my B is 461.904. So I'm going to put 461.904 squared plus C is 150 squared minus A 600 squared divided by 2 times B is 461.904 times C is 150. And when I calculate that, I get 153.6 degrees. So this angle here is 153.6 degrees. Now the ship is headed this way. I want to know the ship is headed in this direction. And what I want to know is how much does it need to turn, okay? So this angle, I need to subtract 153.6 from 180 to know what this angle would be here. So 180 minus 156, I'm sorry, 153.6 will equal 26.4 degrees. So the captain should make a course correction of 26.4 degrees to head to Barbados. Finally, how long will it take the ship to arrive in Barbados once they've made the course correction? So I know the distance that the ship is from Barbados is 461.904 nautical miles, and then we're going to divide that by 15 nautical miles per hour. And that will give us about 30.8 hours, or roughly 31 hours.